Today, we'll continue our discussion on cloud security and cloud computing. In the previous lecture, we've already defined what is cloud security. We have seen the type of attacks, and we have also understood what are threats and why threat modeling is necessary. So almost all software systems today, they face a variety of threats. These threats can be from within the organization or from the outside, and the impact of these threats has potential to be devastating. So threat modeling methods, what they do is they allow the users to create an abstraction of the system and allow them to identify the profile of potential attackers and also prepare a catalog of the potential threats that may arise. So today we'll look at various threat models which are available in the literature, and we'll discuss one in detail. I have listed here 12 threat models which are available in literature. So let us initially look at these, and then we'll do one model which is the most popular one and the most mature by far, that is STRIDE model. So the first model is a STRIDE model. Its advantage is that it is easy to use, though the execution is slow, but it is the most mature model till date. We'll come back to this model. Then is a PASTA model. In PASTA model, there are 7 stages, and each of these stages again has multiple activities. So that is why this model is very, very laborious. Though it has rich documentation, but it is extremely laborious. The 7 stages are like, it first defines the objectives, and then it defines the technical scope, and then application decomposition. Then it does the threat analysis, and then vulnerability and weakness analysis, then attack modeling, then risk and impact analysis. So this technique helps to identify relevant mitigation techniques. It directly contributes to risk management. It encourages collaborations among stakeholders. It also contains built-in prioritization of the threat mitigation. That is, which mitigation technique should be used first, and then which is the next, and so on. But the issue is it is very, very laborious due to the 7 stages which which has to be covered one by one. The third model is Linden. So here this is mnemonic. L stands for linkability, I is identifiability, N is non-repudiation, D is detectability. This D stands for disclosure of information, U is for unawareness, and N is for non-compliance. So Linden actually starts with a data flow diagram of the system and defines systems data flow processes and external entities. It iterates all the model elements and analyzes them from threat point of view. So again, this method can be very, very labor intensive, and it is not very easy to use. CVSS, the Common Vulnerability Scoring System. So this model was developed by NIST. So in this model, a CVSS score is calculated. The equations which are used in this process are not clear, but all the metrics which are used are explained well in the documentation. So this has score calculations, but they are not transparent. Next, attack trees. So, attack trees are essentially a tree diagram that depicts the attack on a system in a tree form. The tree root is the goal of the attack, and the leaves are the ways to achieve it. And each goal is represented by a separate tree. Thus, the system analysis produces a set of tree attacks. Then each of them can be used to mitigate the attack. So it helps identifying relevant mitigation techniques. So it's a diagrammatic technique. Also, it has consistent results when repeated. It is easy to use if you have thorough understanding of the system. But in case the system understanding is not clear, then using this diagrammatic technique or threat modeling method is not recommended. Next is persona non grata. So this threat modeling, which in short is called as PNG, focuses on the motivations and skills of human attackers. So the idea in this model is to introduce a technical expert to a potential attacker of the system and their skills, motivations, and goals that help the expert to see the system vulnerability and point of compromise from the other side. So basically, in the system, attacker tries to see that if attacker will attack this particular system, then in what ways it can be done. But this model tends to detect only some subsets of the threats. So again, it is not very widely used. Security cards. So security card is a technique that centers on identifying unusual and complex attacks. Now, it is not a formal method, but more of a brainstorming technique. So with the help of a deck of card, the analysts will ask questions like questions about an attack, like by whom, why the attack was done, what were the assets of interest, and so on. So this method uses a deck of 42 cards to facilitate the threat discovery activities. However, it leads to many false positive results. Next is a hybrid threat modeling method, HTMM. So this was developed by Software Engineering Institute in 2018. It has basically 5 main systems. First is to identify the system that has to be threat modeled. Second is to apply security card based on the developer's suggestion. Third is remove unlikely PNGs, that is, there are no realistic attack vectors. Fourth is to summarize the result using tool support. And fifth is to continue with a formal risk assessment method. So this technique has been applied on one of the cyber physical systems, and it has consistent results when repeated. Next is quantitative threat modeling method, that is QTTM. So this is a hybrid method. It consists of attack trees, STRIDE, and CVSS methods, all of them applied together. So in this method, the first step is to build attack trees for the 5 threat categories of STRIDE, and then after that it applies the CVSS method and scores are calculated for the components of the tree. This also has consistent results when repeated. Our next method is Strike. It was created as a security audit framework in 2005, and it uses threat modeling as a technique. It looks into threat modeling from a risk management and defensive perspective. However, it has a very vague and insufficient documentation. Next is a VAST model, that is visual, agile, and simple threat. So this method was created based on Threat Modeler, which is an automated threat modeler platform. The fundamental value of method is scalability and usability that allows it to be adopted in large organization throughout the entire infrastructure. That is, it is explicitly designed to be scalable. However, it has little documentation which is available publicly. And finally, the last model is Octave. So Octave is a risk-based strategic assessment and planning method for cybersecurity. And it has three phases. First is to build asset-based threat profile, identify infrastructure vulnerability, and to develop a security strategy and plans. This method is also again very time consuming and has very vague documentation. So not all the modeling methods that we have discussed are comprehensive. Some of them focus on abstraction and encourage granularity, while others are more people centric. So threat modeling can be combined to create more robust and well-rounded viewpoint of potential threats. Selection of these threat model depends on focus, time frame for analysis, experience of modeling, etc. So we'll discuss one model, that is the STRIDE model, in detail. Let us look at this threat model. So in this STRIDE model, which is the most popular model by far, let us look at the STRIDE model in detail. So in this S in the STRIDE stands for spoofing. Spoofing means pretending to be something or someone else other than yourself. So, spoofing identity, this threat violates the authentication of a user. Then is tampering. Tampering will violate the integrity of the data or the resource. So tampering means modifying something on the network, on the server, on the disk, or elsewhere. Third is repudiation. Repudiation means claiming that you didn't do something or were not responsible for some action. So this claim can be either true or it can be a false claim. Then is information disclosure. Information disclosure, so threat on information disclosure may compromise on the confidentiality of the data. Basically, it means providing information to someone who is not authorized to access it. Then denial of service, which compromises on availability of the data. So denial of service refers to exhausting resources needed to provide service. Finally, elevation of privilege, which means allowing someone to do something that they're not authorized to do. So this compromises on the authorization. So in the STRIDE model, it deals with these 6 threats. So in today's lecture, we saw various models which are available for threat modeling in literature. In the next coming lecture, we will be discussing more precisely about cloud security. Thank you.